complex probabilities, we have to learn about where our data is contained. Well, this is the sample space. There are three major ways that we organize our data. We use the curly brackets. We put all our data inside of them, separated by commas, or we can use a Venn diagram. You've seen these before. Or we can use a matrix list. Here's what I mean. Let's say we were rolling one die. What would our sample space be? Well, we can put it in the curly brackets. We can roll a 1, a 2, all the way to 6. That would be an easy way to sort our data. What happens if we roll 2 dice? What happens then? Well, we could roll a 1 and a 1. We can roll a 1 and a 2. We could also roll a 2 and a 1, right? Notice, the 1 and the 2, and the 2 and the 1, they repeat. They both have a sum of 3. And we continue on all the way until we get a 6 and a 6. This way seems a little bit more difficult. Let's find another way. Let's try putting the sum of 2 dice rolled in a Venn diagram. Well, in the first place, we can have 1 and 1. The second one, a little bit larger, could be a 1 and a 2, or a 2 and a 1. Third one, even larger, it could be a 2 and a 2. It could be a 3 and a 1, and a 1 and a 3. It repeats again. This way is seeming a little difficult, just like the last one. Let's try a different way. Let's try rolling 2 dice and sort our data in a matrix. It might be easier. Let's say the first dice roll, die number 1, has a chance of being a 1, a 2, a 3, 4, 5, all the way to 6. The second dice roll has the same value. A 1, 2, let's just separate it like that. So we have the first time that we have a chance of 1 and 1 that has a sum of 2. First time we roll is a 1, then we roll a 2 that has a sum of 3. 1 and 3, that's 4. You see a pattern? We can do it that way. And we can do it down here too. 2 and 1 is 3. 2 and 2 is 4. You see the same pattern? Right? You got 2, 3. I bet you this one's going to be a 4. 3 plus 1? Yep. All the way straight across. And we can continue to fill it until we get our whole sample space filled. Notice that there's only one way that you can get a sum of 2, rolling a 1 and a 1. There's only one way to get a sum of 12, rolling double 6s. How many ways can you roll a 7? 1, 2, 3, 4, 5, 6. 6 different ways. Out of how many? But what is the sample space size? Well, we multiply 6 times 6, or 6 squared, to get 36. That means our n equals 36. So there are 6 possibilities or different ways of getting a 7 out of 36. So the probability of rolling a 7, you guessed it, 6 out of 36.